Let's look at theory of errors in this video. This theory is used in the analysis and interpretation of scientific measurements. Take note that chemistry is an experimental science and it deals with things that can be measured. That's like pressure, temperature, concentration, volume, and so on like that. Take note that what measurements is always accompanied by some mistakes known as error. At times, your value might deviate from the original value you are required to get. So no measurement is perfect. Errors will always be encountered. Now, take note that whenever we measure, we are to display three things. A complete measurement. Take note that a complete measurement must have three things. The first one is the value or the magnitude. Your measurement must have the magnitude or value. Also, it must have the standard of comparison. It must have the standard of comparison. And lastly, your measurements must have the uncertainty. Good. A complete measurement must have these three things: the value or the magnitude, the standard of comparison, or we call it the units, then we have the uncertainty. For example, if I measure something like, let me say 2.5 meter, then plus or minus, let me say 0.1. Or let me put the unit here like plus or minus 0.1, let me say meter. This is how a complete measurement should look like. Now take note, you see this 2.5. You see this 2.5 here is the magnitude we are talking about. That is the real value, magnitude. And you see this one here is the uncertainty. Uncertainty. This is the uncertainty. Okay. Why this is the unit? Your measurement must contain these three things: the magnitude, the unit, and the uncertainty. Now, let's continue. So this topic is actually really, really important because it will help you find out small mistakes that arise from measurements. It will also help you to calculate how big or how small those mistakes are. And it will guide you on how to make sure that your final result is as accurate as possible as an experimental scientist. Okay, take note that we have two types of errors. So look at errors. Let me erase this. We have two types of errors. So look at errors. So they are of two types majorly. So we have the determinate errors and we have the indeterminate errors. Indeterminate errors. Good. Now these are the two types we have. Now take note that this is further divided into what? Into constant error, and we also have the second one, which is the systematic error. Good. Now these are the type of errors we have. So let us start with determinate errors. So we're starting with determinate errors. So let's start with this. So what are determinate errors? You see, determinate errors arise from these three things. Number one, determinate error can arise from the analyst. Let me say the person performing the experiment. Determinate error can occur from the analyst or the person performing the experiment, or you can say from the observer. Can arise from the observer. Also, this determinate error can also arise from faulty equipment. Faulty equipment. Good. Exactly. So determinate error arises from actual mistakes, either from the observer or from faulty equipment. Yeah, either from the observer or faulty equipment. Okay, let me take for instance that we all know that to start titration, you must always remove the funnel from the burette. Let me say this analyst left the funnel like that to perform what? The titration. You know that what error will surely occur. That is the mistake from the what? From the observer or the analyst. Similarly, we all know that to perform titration, we must always use a pipette whose mouth is not broken. So if the mouth of the pipette is what is broken and the person is using it that way to perform the experiments, take note that the type of error that will occur will be due to what? Due to faulty equipment. Let me take for instance again that this observer was unable to determine the color changes. That is, let me say the color from, let me say from purple to colorless. This person was unable to discover what? The color change. So that is error from the analyst. Also, if this person is using, let me say they are using what? An equipment that is not well calibrated. So that error will be due to what? Faulty what? Equipment. And that's about determinate error. We call it determinate error because the source of the error can be determined. Yeah. It can be what? It can be determined. It can be measured. Are we together? Good. All right. So let's go to the types of what? Of determinate errors. Let's go to the type of first, let me explain these two. When you hear the word constant error, what are constant error? The meaning of constant means when something does not change. Constant errors is the same for all measurements. They don't vary. They are same for all measurements. Constant error are what? Are same for all measurements. It does not change at all. Okay, let me take for instance that we are making use of a scale.
Sorry. That's what
Let me take note that we are making use of what? A scale. And this scale, let me say, look at this scale now. Normally, it should be balanced at 0. It should be balanced at 0. Now, let me say an object was placed here and we don't even know at all. An object was placed here. Pay attention to this. An object was placed here and let me say this object weighs 1 gram, for example. Now, take note of something that if you place any object here to measure, let me say the real mass of this object, let me say the real mass of this object is 20 gram. Now tell me, if I put this on this scale, let me raise the 0. Now, if I put this 20 gram on this scale, can you tell me what will be the total mass? The total mass will be what? 21 gram. Meanwhile, the real mass of this object placed in this plate here was 20 gram. Also, if I'm using this same scale to measure another object and the mass of this object here originally is 5 gram and this object is still there, can you tell me what will be the reading of this balance? The reading of this balance will be what? 6 gram. You observe that what? This error is constant for all of them because this 1 gram was placed there and it will be constant for everything you are measuring. If you are measuring an object whose mass is 16 gram, if you put it on this scale, it will be measuring what? 17 gram just because of this 1 gram that is there. So that is constant error. It does not vary. It's the same throughout the measurements. That means of the word constant. When something does not change, that means of the word constant. Okay, that's constant what? Constant error. Now, what is the second one is what? Is systematic error. Just opposite of this. Systematic error vary. Constant error is the same for what? For all measurements. Systematic error vary from one measurement to what? To another. Vary from one measurement to another measurement. And that is it. Vary from one measurement to what? To another measurement. That is what? Systematic what? Error. So let's look at the types of determinate errors now. Let's look at what types of determinate errors. So we are looking at types of determinate errors. So let's look at types of determinate error and explicit explanation on them. So the first one is instrumental or reagent error. Now, what is instrumental or reagent error? This is very, very simple. You see, when I'm talking about instrumental error, it means that we are talking about the error that arises from the apparatus we are making use of. That is, this error is when we make use of what? Faulty equipment. Faulty what? Faulty equipment. Instrumental error arise from what? From faulty equipment, e.g. uncalibrated apparatus. Are you there? There are some apparatus that will have zero error and so on like that. So that's an example of what? Instrumental error. And what is reagent error? Take note that for our reagent to give us the best result, it must be pure. So if this reagent contain impurity, if there's an impurity in this reagent, if this reagent has some impurity in it, it means that what? We'll have reagent error. It's very, very simple. Because this impurity can create some side attractions in the what? In the experiment. Hope you get that. So instrumental error arise from faulty equipment, while reagent error arise from what? Reagents that contains what? Impurity. So that's about that. So the next one is the operative error. The next one is the operative error. The operative error. Now, what is this operative error? This operative error is just based on carelessness. Carelessness or inexperience of the analyst. Inexperience of the analyst. So let's explain what this means. Operative error, carelessness or inexperience of the what? Of the analyst. Now let me tell you something. You see, the fact is that, let me say you are calling let me say you are calling a quack chemist to come and carry out a professional experiment in chemistry. Let me say titration, for example. Now, this quack chemist won't know the guideline on the rules and guideline of the experiment. For example, we all know that it is not advisable. Let me say this is our beaker for the titration now. We all know that what? It is not advisable to use, let me say, white handkerchief to clean the inside of this beaker. This is because to avoid impurity. But what happened? This analyst will perform that just because you want the beaker to be clean. And that's what operative error. That is inexperience. Also, if the person, let me say you are performing titration now, and this is your burette. For example, this is your burette. This is your burette. We all know that we don't leave the funnel at the top of the burette while the titration is going on. But what happened? This analyst will do this. Why? In what? Inexperience or carelessness of the what? Of the analyst. And that is it. The next one is, so the first one is instrumental or reagent error. The second one is operative error. The third one is what? Is we have personal error. Now, you have to be careful about operative and personal error. It might seem the same, but they are entirely different. You see, the personal error is based on this person's internal problem. Yeah, that's the easiest way to know it. This person's internal problem. Now, for example, see, at times, some people don't know how to determine color change. And that's an example of what? Of personal error. At times, some people at times we have bad sense of taste. That's personal what? Personal error. So personal error is what? Is the inability of the what? Of the individual to make observation correctly. Are we together? The inability of the what? Individual to what? To make observations correctly. For example, if this analyst cannot make observation on color change during titration, that is what? That is personal what? Error. In salt analysis, if the person cannot what? Distinguish between purple or purplish black, or those color can resemble. So that's the person's fault. Some people are color blind, and that's an example of what? Personal error. Next one is what? Error of method, or we call it methodical error. Methodical error. So what is error of method? Now, you see, error of method happens when there is a problem in the experimental setup or procedure. That is, let me say you are using a particular method to carry out a reaction. If there's a problem with that method use, you are going through what? Methodical error. Methodical error can be eliminated just by you changing the method you are using entirely. That is, change the method you are using what entirely and bring another method. Let me give you an example of methodical error. Now, for example, if a chemical reaction is to be carried out at a specific temperature, let me say it's to be carried out at 60 degrees Celsius, and you are now using a method that cannot maintain this temperature. Let me say you are using a method that cannot what? That cannot maintain what? This temperature. What happens? This will constantly what? Affects your what? Your result. So therefore, you have to change the method you are using entirely to fit in with this what? With this temperature. And that is what? Methodical what? Error. Now, what are the characteristics of determinate error? You can know that with determinate error, I've said that before, it can be measured. It is measurable. Are you there? It is measurable. And take note that what? Your determinate error reduces accuracy. Reduces accuracy. It reduces what? Accuracy, yeah. And take note that what? It does not affect precision. In my next video, you understand the basic difference between accuracy and precision. So this one does not affect precision, okay? Only affects accuracy. Take note of that. Okay, so what are the methods that can be used to reduce determinate errors? What are the methods that can be used to reduce determinate errors? So there's a way you can even learn it by summarizing it this way. So the first one is this. You see, first one, remember that this, yep, okay, let me write minimizing determinate errors. Minimizing determinate errors. Now, remember that this determinate error arises from equipment, faulty equipment and reagents. So the first one is that calibration of apparatus. Calibration of what? Of apparatus. That's the first one. Okay, calibration of apparatus. So those apparatus that are not well calibrated should be calibrated, and doing that, you have minimized determinate error. And what type of determinate error did you minimize? You have minimized what? Instrumental error. So next one is by running some determination. Running determination. Running determination. What type of determination now? There are three in numbers, I think. So the first one, we have a blank determination. Next one, we have control determination. And third one, we have a parallel determination. So these are three types of determination. So we can run blank determination, control determination, or parallel determination. So the next one, we have isotopic dilution. Isotopic dilution. The next one, we have use of internal standard technique. Internal standard technique. And lastly, we have what? Using independent method of analysis. Independent method of analysis. Independent method of what? Of analysis. So that is it. So that is what? That is that on determinate errors. Now let's look at indeterminate errors. Let's look at indeterminate errors. Now, from the word indeterminate, it means that, excuse me, this indeterminate error is trying to tell us that what? This error is beyond the observer. It's not, you see, the source of this error cannot be what? Cannot be determined. Okay, let us look at example. You see, there are some errors that are beyond the analyst or the observer. So this indeterminate error is error that what cannot be determined and cannot be what? Cannot be accounted what? Cannot be accounted for. Are we together? So the accumulated effect of this indeterminate error causes replicate measurement to what? To fluctuate. It causes what? Let me say I'm taking some measurement now. So the measurement will be what? It will be fluctuating around the mean. For example, I can have, let me say 2.1. Let me say next I can have 6.3. Next I can have 4.2. Next I can have 6.0. So this value will be what? Will be fluctuating around the what? Around the mean. So in a nutshell, indeterminate error, the sources cannot be determined. Okay. So let me give us some differences between determinate and what? Indeterminate error. Okay, let's go. Look at the first one. Here, Number one, this one can be measured, it is measurable. Or let me say the source can be determined. Let me say the source can be determined. So source of error can be determined. Why this one? The source cannot what? Cannot be determined. The next one, this error can be avoided. Yeah, can be avoided. Okay, this can be avoided, but this cannot be avoided. This cannot be avoided. Are we together? So that is it. So we can actually trace the source of error, but we cannot trace this source of error. Okay. So and take note that what indeterminate error has a name we call it. So we call it random errors. So we call it what? Random what? Error. So it means that what determinate error can either be what? Can either be constant, or systematic. This can either be constant or systematic. Why this one is just what? It's just what? Can just be what? Can just be random. So these errors are constant or systematic, while this one are what? Random. So that is that for that on errors. So subscribe to this channel and click the notification bell and expect more videos on theory of errors. So I'll still be discussing the precision and accuracy and some method of combining errors.